Do now for 11.2, angle FGH is 126 degrees. This is the exterior angle. Angle HGJ is right here. This is adjacent to the exterior angle, which means angle H and angle J are what we call remote angles, since they're interior but non-adjacent to the exterior angle. We have this formula called the remote exterior angle formula that says that angle H plus angle J has to equal the exterior angle. So when I combine together angle H and angle J, I get 11x plus 16. And that's going to equal the exterior angle, which is 126. Do all your math, you get x equals 10. When I plug it back in, I get 59 degrees for angle H. And I get 67 degrees for angle J. And when you add those together, you get 126. Okay, last week we talked about the triangle inequality theorem, and the triangle inequality theorem said if you're given all three side lengths, can these three side lengths, 3, 5, and 6, form a triangle? Well, in order for us to figure that out, what we did is we added together 3 and 5. We got 8, and 8 is greater than 6. And then we added together 5 and 6. We got 11, and 11 is definitely greater than 3. And then the last combination was 3 and 6 added together is 9, and 9 was greater than 5. Well, we can use this triangle inequality theorem when given two numbers, two side lengths, 3 and 4, and I'm trying to find the third side length. So I know 2 out of the 3 side lengths. It kind of follows the same concept. When I add together the first 2 side lengths, 3 and 4, that has to be greater than x. Well, if I solve for x, 3 plus 4 is 7. 7 has to be greater than x, which means x has to be less than 7. And then I can take the first side length and the last side length, 3 plus x, and that has to be greater than the second side length, which is 4. Subtract 3 from each side, and you get x is greater than 1. So x has to be less than 7 or greater than 1. Well, there is a third inequality, which would be 4 plus x has to be greater than 3. But when you solve this inequality, we get x is greater than -1, and side lengths cannot be negative on a triangle. So the way we write our final answer looks like this. 1 less than sign x less than 7. We write this at like our domain and range in Algebra 1. X has to be greater than 1 but less than 7. So over here with example 2, we're given 5 and 8, and we have to find the third side length. So our first one's going to be 5 plus 8 has to be greater than x. Add 5 and 8 together, you get 13. X has to be less than 13. Then we have 5 plus x has to be greater than 8. Subtract 5 from both sides. X has to be greater than 3. We use the third inequality, which is 8 plus x has to be greater than 5. We end up with a negative number, so that inequality doesn't work. So our answer is 3 less than x less than 13. X has to be greater than 3 but less than 13. That's just an application of the triangle inequality theorem. So when you had a right triangle, we knew if we knew 2 side lengths, we could find the third side length by using Pythagorean theorem. A squared plus b squared had to equal c squared because it was a right triangle. Well, if a squared plus b squared is greater than c squared, then the triangle is actually going to be an acute triangle. And if a squared plus b squared is less than c squared, then the triangle actually is going to be an obtuse triangle. I'm going to change this side length to 10. Change the side length to 6. So my C has to be the largest side on both of these. So what I'm going to do is 3 squared plus 8 squared. And I don't know if that's going to be greater than, less than, or equal to. So I'm going to put a question mark in between the two. Well, 3 squared plus 8 squared, that's 16 plus 64. 3 squared plus 8 squared, that's 9 plus 64. So it's going to be 73. And 10 squared is 100. And 73 is less than 100. That means this triangle is an obtuse triangle. Over here, our example is 4, 5, and 6. Those are 3 side lengths. We're going to take 4 squared, add it to 5 squared, and we're going to see if that's less than, greater than, or equal to 6 squared. So that's 16 plus 25. It's going to be 41. 6 squared is 36. Well, 41 is greater than 36. So what type of triangle do we have? We have an acute triangle.